Welcome to the Wind Sustainability series. This is episode number 4, Single Engine Taxi Out. In this video, we are going to talk about what you can do as a pilot to reduce aircraft emissions thanks to single engine taxi out. Let's take an example. On the A320, this saves approximately 12 kilograms of CO2 per minute. Single engine taxi procedure for twin engine aircraft or two-engine taxi procedure for four-engine aircraft is available in the FCOM for all Airbus aircraft types. Airbus highly recommends single-engine taxi out when conditions permit at departure. However, as a pilot, it's important to be aware of the associated threats. This is why I would like to highlight the importance of threat and error management. Because only one engine is running, additional thrust may be required. There is a risk of jet blast and foreign object damage. Starting an engine during taxi requires time and attention. This must not have a negative impact on situational awareness and the correct application of procedures and checklists. In line with the competency-based training and assessment and evidence-based training concepts, the pilot competencies are powerful barriers to manage threats and errors. Let's start with communication. The flight crew should discuss when and where they will start the remaining engine. The objective is to share in advance the action plan. Communication and coordination are required in order to avoid any startle effect when one crew member starts the engine. Communication with cabin crew may be required, for example, if electrical load shedding is expected. Single-engine taxi without APU may affect galleys or IFE depending on the configuration of the aircraft. If the aircraft stops in a congested area, communication with ATC may be necessary before increasing thrust in order to ensure that no ground personnel is around the aircraft. Now, in terms of knowledge, understand the effects of single-engine taxi with or without APU. Understand the importance of warm-up time for the engines. Then, be aware that the procedure associated with single-engine taxi may change between aircraft configurations. Knowledge about the airport includes a gate, ramp, and taxi route. Some uphill slopes, sharp turns, or congested ramps may prevent single-engine taxi or make it more difficult. In addition, you should know the restrictions that may apply at specific airports as published in the applicable charts. Maintaining situational awareness during single-engine taxi is very important. At any time, be aware of the level of thrust, the position and direction of your aircraft and its technical status. Be aware of your surroundings, ground personnel, other aircraft, etc. If installed, the airport moving map, ADS-B or taxi cameras can be helpful, as well as listening to the ATC frequency. Be aware of the weather conditions. Slippery surfaces may prevent single-engine taxi out. Tailwind on the taxiway may make the engine start more difficult. Time. Be aware of when the engine must be started in order to respect the warm-up time. Be aware that time pressure increases the risk of errors, especially if performing several tasks at the same time. Let's focus now on an essential competency, workload management. It's important to plan and anticipate tasks in order to avoid rushed actions when approaching the takeoff runway. Anticipate the time necessary to start the other engine and do the remaining actions before takeoff. Prioritize tasks in an appropriate way and delegate when necessary. In the case of excessive workload, it may be necessary to stop the aircraft. Problem solving and decision making. Check the available sources of information in order to decide if a single engine taxi is possible. For example, airport charts, meteorological information, ATC. At some airports, the ATC can provide you with an estimated taxi time. Keep in mind that the decision to perform a single engine taxi should be compatible with the status of the aircraft. At any time, if the flight crew considers it necessary, they can decide to start the other engine. Be aware that when you start the remaining engine, a failure is possible. Be aware of your company's MEL policy for failure management during taxi and the possible decision to return to the gate. To conclude, we saw what are the essential competencies for single-engine taxi out. Keep in mind that single-engine taxi reduces CO2 emissions during the taxi phase. The CO2 savings may appear small from an individual flight perspective, but fleet-wide, single-engine taxi definitely makes sense. That's all for today. Thank you for watching this episode of the Wind Sustainability series. Stay tuned for more on how to reduce fuel consumption and CO2 emissions during the other phases of the flight.